Hello everyone. In today's class we shall discuss about traveling salesman problem. As you all know students, salesmen are those persons whose job is selling and promoting the product either in their shops or by visiting the different locations. Okay, those persons are said to be the salesman. Okay, these traveling salesman problems are done to find out how the salesman should travel to different cities so that the distance can be minimized. If the distance is minimized, then the time as well as cost can also be minimized. Okay, so to find out that sequence, this traveling salesman problem is done. The traveling salesman problem is done, students, by using the Hungarian method. In this problem, students, there are two additional conditions. So what are those additional conditions, students? We shall read it now. The traveling salesman problem may be solved as an assignment problem with two additional conditions. Okay, on the choice of assignment, that is, how should a traveling salesman travel starting from his home city, the city from where he started, that city is known as home city, and visiting each city once and returning to his home city so that the total distance, that is cost or time covered, is minimum. Okay, so the objective is to select the sequence in which the cities are visited in such a way that his total traveling time is minimized. So here, students, the two main conditions are he should start from his home city, and next he should visit each and every city only once and then return to his home city. These two conditions should be satisfied in the problem, students. In today's class, we shall do two different problems on traveling salesman method, students. So this is the problem number 1. So this is the question right here. So a traveling salesman has to visit 5 cities. He wishes to start from a particular city once and then return to his starting point. Okay, the traveling cost is in 1000 rupees, students, of each city from a particular city is given below. So students, there are 5 cities, A, B, C, D and E. Okay, this is from city and to city. Okay, so students, these once have a look on this diagonal cell, students. The infinity value is given, which is nothing but to travel from A city to A city, the traveling cost is 0. So they had given the value infinity value. Okay, next student, to travel from B to B, again the value is infinity. Next, to travel from city C to again C, the value is, since there is no logic, the value is 0, they had given only infinity. Okay, next from city D to city D, the value is infinity, and E to E, the value is infinity. So to travel from city A to B, the total cost is, students, 2, that is, it is given in rupees 1000, so 2000. From A to C, the cost is 5000. From A to D, the cost is 7000. From A to E, the cost is 1000. Next, from B to A, the cost is 6000, students. From B to B, the value is 0, so they had given infinity. So from B to C, the cost is, students, 3000. So this is the cost of traveling the salesman. Since traveling to the same city, students, the cost will be 0. They had assigned a value infinity in place of that 0. That's it. Okay, so students, from city A to city A, the cost is 0. They assigned an infinity value. That's it. From city B to again city B, the cost is infinity value they had assigned. From city C to C, again infinity, D to D infinity, and E to E infinity. The diagonal cell will have an infinity value. Okay, students. So in the next step, students, we have to do the same procedure that we have already learnt under Hungarian method. Okay, in the first step, students, we have to do the row operation. Next, we have to do the column operation. Next, we shall do the row scanning and column scanning. Okay, so students, they are asking us to calculate what should be the sequence of visit of salesman so that the cost is minimum. We have to find out the sequence, students. There are two conditions to find out that sequence. So the first condition is, students, the traveling salesman should start from his home city and visit each and every city only once and then return to his home city. Okay, so students, we shall start our solution. The first step is to do the row operation, students, as we have did in a number of problems. Okay, how the row operation is calculated, students? By taking the first row, students, the minimum value here is 1. In the second row, the minimum value is 2. In the third row, the minimum value is, students, 4. In the fourth row, the minimum value is 4. Next here the minimum value is 1. The row operation is done by subtracting the minimum value from the remaining elements in that particular row. So infinity, so here the infinity will be as it is, students. 2 minus 1, 1, 5 minus 1, 4, 7 minus 1, 6, 1 minus 1 will be the 0. Next 6 minus 2, 4, infinity. Next 3 minus 2, 1, 8 minus 2, 6, 2 minus 2, 0, as so on, student. This is the row operation. And the next step is to do, students, the column operation. Okay. In the column operation, students, we have to do the column operation from the row operation only. In the first column, student, the minimum value is 0. In the next column, the minimum value is again 0. Here the minimum value is 1. In the fourth column, the minimum value is 0. And in the fifth column, the minimum value is 0. We have to subtract the minimum value from the remaining element in that particular column. So infinity as it is. Next 4 minus 0, 4, 4 minus 0, 4, 8 minus 0, 8, 0 minus 0, 0. Okay, next in the next column also 0, the same value will come. And in the next column, the minimum value is 1. So 4 minus 1, 3, 1 minus 1, 0, infinity as it is. Next 2 minus 1, 1, 1 minus 1, 0, and so on. This is the column operation. Our next step is to do the row scanning and column scanning, students. Starting from the first row, we have to check whether there is 1 0 or more than 1 0. If there is 1 0, then assign a square mark to that 0 and draw a vertical line crossing that 0, as we have discussed in our previous classes. Okay. In the column scanning, students, in that particular column there must be only 1 0. Assign that square to that 0 and draw a horizontal line. So students, starting from the first row, I am doing the row scanning. Starting from the first row, check in this row there is 1 0. Okay, there is exactly 1 0, students. Give a square mark to that 0 and draw a vertical line crossing that 0. Okay, and next coming to the second row, students, check whether there is 1 0 or more than 1 0. Students, there is only 1 0 in the second row. This 0 has been deleted, so give a square mark to that 0 and draw a vertical line crossing that 0. And next in row C, students, there is again 1 0. Give a square mark and draw a vertical line. Next in row D, students, there is again 1 0. Draw a vertical line crossing that 0. Next in row E, there is again 1 0, students. Give a square mark and draw a vertical line. So students, we have covered all the zeros through line, students. Next for column scanning, no need to do the column scanning, students, since all the columns has been cancelled. Okay, this is the assignment, students. Since all the zeros has been covered, students, no need to do the column scanning. And the next step is to check whether the number of squares are equal to the number of rows. Okay, how many squares we have obtained, students? 1 2 3 4 5. So there are 5 rows. Since the number of squares are equal to the number of rows, we have reached the optimality. The next step is to give the check the sequence, students. Okay, so students, from city A, the salesman is traveling to the city E. Here the square mark is near the city E, students. From A, he is traveling to E. Okay, next from B, he is traveling to C. Next from C to D, next from D to B, and next from E to A. Okay, so this is the sequence we have obtained. Clear? The next step is to check the conditions, whether the conditions is satisfied or not. The conditions are, student, that salesman should travel from his home city, visiting each and every city, and then return back to his home city. Okay, we shall check whether this problem is satisfying the condition or not, students. From A, he is traveling to E. From A, he is traveling to city E. Okay, from E, he is traveling again to A only, students. Okay, clear everyone? So once again I will repeat it, students. From city A, he is traveling to E. Okay, from city E, he is again traveling to city A. He did not travel the remaining cities, that is B, C and D cities. He did not travel. Clear everyone? So this sequence does not satisfy the condition. Okay, since this sequence has violated the condition, students, the salesman has to travel starting from his home city and visit the each and every city and then return to the home city. But in this sequence, students, the salesman has not traveled to the remaining city and returned twice to the home city. Okay, so students, at this situation, the solution can be obtained by the next step, students. Once have a look. The next best solution can be obtained by making the unit assignment. Okay, the unit assignment is nothing but, students, assigning a square to the non-zero element. okay, which is the minimum element in a matrix. That assigning to that non-zero element is known as unit assignment. Okay, assigning a square to the non-zero, that is minimum element, and then that row and column should be eliminated. Okay student, this is the condition to get a optimum solution for the problem. Clear students? I have written as it is the matrix here students, same matrix I have written to get the sequence students. Here in this matrix the minimum non-zero element is students, what is the minimum non-zero element here is 1. Okay, how many 1 are there students? 1, 2, 3. I can assign a square mark to these non-zero elements. Clear everyone? Okay, so students, I can do the unit assignment here. I can give a square mark to the non-zero minimum element. Here the non-zero minimum element is 1. So here there are in 3 places there is 1 students. So I can give a square mark to this 1 value. Okay, so this is known as unit assignment. Wherever I give an unit assignment, I have to cancel that row and that column. Clear everyone students? So I'm doing the row scanning students, starting from the first row. Okay, so there is 1 0 students. If I give a square mark to this 0, the same procedure repeats. Yes or no? So I am doing the unit assignment. I am giving a square to the 1 value. Okay, so whenever the unit assignment is done, we have to cancel that particular row and that particular column. Clear? Okay, next coming to the second row students, there are 2 zeros and there is no non-zero element, so leave it. Next, in the column C students, there is only, in the row C student, there is only 1 0. Assign a square and draw a vertical line crossing that 0. Okay, in the row D students, there are 2 minimum value students. Okay, there are 2 minimum non-zero value, that is here 1 and here is also 1. I can give a square to any one of these students. Okay, for example, if I give a square to this one, okay, for example, if I have given a square to this one, then this particular row and particular column should be cancelled. Clear everyone? Next, coming to the row E students, only 1 0 is left, so give a square mark to this 0 and draw a vertical line crossing that 0. Next, check whether all the zeros has been covered students. No, there is still 1 0. We have to do the column scanning students. All these 4 columns has been cancelled. In the last 5th column, only 1 0 is left. Assign a square mark and draw a vertical line crossing that 0. Okay, so students, next we should check the sequence here. From A city, that salesman is going to B, from A to B. Next, from B he is going to E. Next, from E he is coming again back to A. So student, this sequence we have obtained from this assignment. Students, the A salesman, starting from his home city, he visited B, and next he visited to E, and next he returned to his home city, but he did not went to the C and D city. Okay, so this assignment is not correct. We have to do the assignment till the optimality has been reached. Clear students? Here there are 2 1. We have selected this one. In our next step, we shall take this one and give a square mark to this in the E column 1. Okay, since this sequence is not satisfying the condition students, we shall try again. Okay, so starting from the first row students, first row I am doing the row scanning. I am giving a unit assignment students, okay, to this 1 value. So whenever the unit assignment is done, we have to cancel that particular row and particular column. Okay, next in second row students, there are 2 zeros, so skip that row. Next, in the third row students, there is only 1 0. There is only 1 0 and draw a vertical line crossing that 0. In the fourth column students, there are 2 non-zero elements, 2 non-zero minimum element. In the last time I have assigned a square to this one, and this time I am assigning a square to this one. Okay, so whenever I have done a unit assignment, I have to cancel that particular row and particular column. Clear? Okay, next, in the row E students, there are 2 zeros, so skip that row. Okay, the next step is to check whether all the zeros has been covered students. No, there are still 2 3 zeros remaining students. Next we have to do the column scanning. We have done the row scanning. Next step is to do the column scanning students. Starting from the first column, there is only 1 0 in this column, so give a square mark to this 0 and draw a horizontal line crossing that 0. The next column has been deleted students. The third column, there is only 1 0 students. Give a square mark and draw a horizontal line crossing that 0. Okay, next column has been deleted. Next has also been deleted. We have covered all the zeros with line students. Next is students, we have to check the sequence, whether the sequence has satisfied the condition of traveling salesman method. Okay, so the sequence will be students, from city A he is traveling to B. From A he is traveling to B. From city B he is traveling to city C. Check where are the square marks students. From B he is going to C. Okay, from C students he is going to city D. From C to D. From D he is going to city E. Okay, going to city E, and next from E he is returning to his home city, that is A. So here the sequence is students, A to B, B to C, C to D, D to E and E to A. This sequence has satisfied the condition of traveling salesman method students, that the salesman should start from his home city and visit each and every city and then return to his home city. Since the salesman has started from the home city A, he visited to each and every city and returned to his home city. So this is the optimal solution student. In the previous solution he went till A to B and B to E only students. So again we have to do the assignment students. We have to do the every possibility till the optimal solution has been reached, and the sequence should satisfy the conditions of traveling salesman method. So this sequence has satisfied the condition students. So next step is to calculate the cost. The next step is students, we have to calculate the total cost. So the salesman is traveling from city A to B students. From A to B, go back to the question students. From A to B, what is the total cost students? 2 plus, next from B to C. From B to C, the total cost is students 3. 2 plus 3, next plus, from C he is going to D students. Okay, from C to D, the total cost is 4. Next plus, from D he is going to E. From D to E, the cost is 5. Plus, from E he is returning to the home city, that is to A, the cost is 1. So the total is students 15. Since the question is given in 1000 students, so the total cost is 15,000 rupees. 15,000. Okay, so this is the optimal solution. Problem students, first step we have to do the row operation. Next we have to do the column operation, as we have learnt in our previous classes by using Hungarian method. Next we have to do the row scanning and column scanning. We have to check whether the number of squares are equal to the number of rows. If the number of squares are less than the number of rows, again we have to take the minimum value from the undeleted cells and deduct it from the remaining undeleted values and then add to the intersection point. Since here the number of squares are equal to the number of rows, we have not done that process. Okay, after getting the number of squares equal to the number of rows, the next step is to check the sequence students. Okay, we have to check whether the sequence is satisfying the condition of traveling salesman method or not. Since this method is not this has not satisfied the conditions given, since he is traveling from city A to E and again he is returning back to A, next we have to get the optimal solution by doing the unit assignment. We have done the unit assignment students by taking here the minimum non-zero element as 1, and we have did the remaining process as we did in our previous classes. Okay, so the total cost of this problem is rupees students 15,000. Clear? Next, problem number 2 students, that a traveling salesman has planned to visit 4 cities. He would like to start from a particular city, visit each city only once and return to the starting city. The traveling cost in rupees is given in the table below. Okay, this is the traveling cost students. We have to find out the least cost route. Okay, so these are all the 4 cities students. So in a previous problem they had directly given the infinity value students to these 0 elements, yes or no? But in this problem students, they had given the 0 values to traveling to the same cities. From city A to A, the cost is 0. From B to B, the cost is 0. From C to C, the cost is 0. And from D to D, the cost is 0. Okay, they can assign 0 value, or else they can directly give the infinity value, students. If they had given the 0 values, then you have to give the infinity values to these 0 values. Okay, so we have to find out the least cost route. Clear, students? So in the first step, students, I am giving the infinity values in the place of these 0 values. Clear? The diagonal cell represents the infinity value, same as it is I have written in the solution. Clear? And the next step is, students, we have to calculate the row operation. In the row operation, students, in the first row, what is the minimum value is 25. In the next row, the minimum value again here is 25. In the next row, the minimum value is 15. Here the minimum value is 65. We have to calculate the row operation, students, as it is infinity. 25 minus 25 0, 75 minus 25 50, 45 minus 25 is 20. Next 35 minus 25 10, infinity infinity, 150 minus 25 125 0, so on. This is the row operation. Okay, and the next step is to do the column operation, students. In the column operation should be done from the row operation only. In the first row, what is the minimum value, students? 0. In the second row, in the first column, the minimum value is 0. The second column, the minimum value is 0. Third column, the minimum value is 50. In the fourth column, the minimum value is 0. Okay, we have to do the column operation, students. Infinity. Next. Actually, students, I am unable to hold my phone properly. Sorry for the inconvenience. So after doing the row operation, next step is to do the column operation, students. So in the first column 0, next column 0 is the minimum value, next 50, and next 0. Okay, so the column operation is here, students. Write infinity as it is. 10 minus 0, 10, 20 minus 0, 20, 0 minus 0, 0. Next column also same values. In this next third column, 50 is the minimum value. So 50 minus 50, 0. Next 125 minus 50, 75, infinity. Next 65 minus 50, 50. This is the column operation. Clear? Next step is, students, we have to do the row scanning and column scanning. So the first row, students, there are 2 zeros, so skip that row. In the next row, students, there is only 1 0, so give a square mark and draw a vertical line crossing that 0. In the next column, students, there is no zeros. In the next row there is no zeros. In the next row there is 1 0, give a square mark and draw a vertical line crossing that 0. Okay, now next step is to check whether the number of whether all the zeros has been covered through lines. No, still there are 2 zeros. We have to do a column scanning. Clear, everyone? Okay, in the column scanning, students, first column has been deleted. In the next column there is only 1 0, so give a square mark and draw a horizontal line crossing that 0. Okay, in the next column, students, there is no zeros left. So our next procedure is to check whether the number of squares are equal to the number of rows. How many squares we had obtained? 1 2 3. Since the number of squares are not equal to the number of rows, how many rows are there, students? 1 2 3. Since the number of squares are not equal to the number of rows, we have to do the improved matrix. We have to take the minimum undeleted value. So what is the minimum what are the undeleted values, students? 75, 25, 10, 9, 15. In these values, what is the minimum value, students? Here the minimum value is 10. Okay, in our improved matrix, this 10 should be subtracted from the remaining undeleted values. Okay, and next this 10 should be added to the intersected points. Clear? Here the intersected point is 20. Clear, everyone, students? We have to add to the intersected point, we have to subtract it from the undeleted values, and the remaining deleted values remain same. So this is the improved matrix here, students. So since infinity, we have to write as it is, infinity, 0 remains same, 0, 20 is an intersection point, students. So 20 plus 10, minimum value is 10, 20 plus 10 is 30. Okay, 10 has been deleted, we have to copy 10, infinity. 75 is an undeleted value, students. 75 minus 10, that is 65. 0 has been deleted, so as it is 0. 20 has been deleted, 20. Next 25 minus 10, 15. Next as it is infinity, 0 has been deleted, 0. Okay, next 0 has been deleted, 0. 10 minus 10, 0. Next 15 minus 10, 5. Next as it is infinity. Clear, everyone? This is our improved matrix, students, which we have obtained. The next step is to do the row scanning and column scanning. Again, students, starting from the first row there are 2 zeros, skip. In the second row there is only 1 0, and give a square mark and draw a vertical line crossing that 0. In the third row, students, there are no zeros. In the fourth row there are 2 zeros. Clear? Next we have to do the column scanning, students. Again, we have, in the first column there is only 1 0, give a square mark and draw a horizontal line. In the next column there is only 1 0, give a square mark and draw a horizontal line. Next, in this column there is no 0. Next step is to check whether the number of squares are equal to the number of rows. How many squares we have obtained, students? 3 squares, not equal to there are 4 rows. Okay, so in these undeleted values, again we have to follow the same procedure, students. What are the undeleted cells? 10, 20, 15, 65. In these undeleted values, what is the minimum value, students? The minimum value here is 10. Okay, so we have to subtract it from the remaining undeleted value and add to the intersected points, and the values which has been deleted remains the same. So here is the another improved matrix, students. Infinity remains same, 0, 0. 30 has an intersection point. 30 plus minimum value, 30 plus 10, this is 40. Next, 10 minus 10, 0. Next, infinity. Next, 65 minus 10, that is 55. Next, 0 has been deleted, 0. Next, students, 20 minus 10, 10. Next, 15 minus 10, 5. Infinity, 0 has been deleted. So as it is, you have to write 0. This whole column, this whole row has been deleted. So same, 0, 0, 5 and infinity. Okay, this is the improved matrix. And again we have to do the row scanning and column scanning. The first row has been, in the first row, student, there are 2 zeros, skip that row. Next row also there are 2 zeros, skip that row. In the next row there is only 1 0, give a square, mark and draw a vertical line crossing that 0. In the next row there are 2 zeros. Clear? So skip that row. Next we have to do the column scanning, students. In the first column there are 2 zeros, so skip that column. In the next column also there are 2 zeros, so skip that column. In the next column, student, there is only 1 0, so give a square, mark and draw a horizontal line crossing that 0. Okay, check whether all the zeros has been covered. No, still there are 3 zeros that are not covered through lines. Again we have to do the row scanning and column scanning again and again. Starting from the first row has been deleted. Next row there is only 1 0, students, give a square, mark and draw a vertical line crossing that 0. In the next row, students, there is no 0. In the last row there is 1 0, give a square, mark and draw a vertical line crossing that 0. This is the row scanning, students. Next we have to check whether all the zeros has been covered. Yes, all the zeros has been covered with lines. So the next step is to check whether the number of squares are equal to the number of rows. How many squares we had obtained, students? 1 2 3 4. Hence the number of squares are equal to the number of rows. We have reached the optimality. And the next step, students, after getting the number of squares equal to the number of rows, the next step is we have to check the sequence. Okay, clear? We have to check the sequence, student. That sequence should satisfy the condition of traveling salesman method. Okay, so from A city, the salesman is going to the C city, from A to C. Okay, from next C, from C he is going to D, from C he is going to D, from D he is going to B, and next from B he is returning to his home city. Clear, everyone? So this is the sequence, students. From A he is going to C, from C he is going to D, from D he is going to B, and from B he is going to A, returning to his home. So the two conditions of traveling salesman method is, students, the salesman should start from his home city and should travel each and every city, okay, and then return to his home city. Since here the salesman has visited each and every city and returned to his home city, that is city A. Clear, everyone? Okay, this is the optimal solution we had. Next step is we have to calculate the total cost, students. The salesman is traveling from city A to C. A to C. What is the total cost, students? Go back to the question. The cost is 75 plus. Next, from C he is going to D. From C to D, the cost is 15 plus. Next, from D he is going to B, the cost is 75 plus. Okay, from B he is going to A, the cost is 35. So here the total cost is rupees 200, students. So this is the traveling salesman problems. I hope you guys understood the topic. In a previous problem, students, we have done the unit assignment. Since the sequence in that problem did not satisfy the condition of a traveling salesman method. Okay, since in this problem, students, the sequence has satisfied the condition, no need to do the unit assignment. Clear, everyone, students? So I hope you guys understood the topic. We shall meet in our next video with the new concept. Okay.